In 1965, co-founder of Intel, Gordon Moore, observed that the number of transistors per square inch on integrated circuits had doubled every year since their invention. Thus, he predicted that the trend will continue into a foreseeable future, and this is known as Moore's law. However, as the transistor getting smaller and smaller, strange behavior of electrons like quantum mechanics starts to occur. Quantum mechanics says that electrons can tunnel through walls and causes a leakage of currents. This resulted as the failure of electronic devices such as transistors. It means the Moore's law will eventually come to an end. The transistor cannot keep shrinking without limit. In order to solve this problem, scientists came up with a brilliant idea. Instead of fighting quantum mechanics, why not using the advantage of quantum mechanics and make it work for us? As a result, these brilliant scientists came up with something called the quantum computer. In the classical computers, bits represent the smallest unit to store information, but you can only store either 1 or 0 in a single bit at one time. However, in the quantum computers, we use something called qubits. Qubits can represent 1 and 0 at the same time. It means we can store more information in a single qubit than classical bits. Qubits can be achieved by several ways, like polarization of photons, magnetization of magnetic field, or the spin direction of the electrons. Today, we will be focusing on the quantum computer that is based on electron spins at its qubits. What does the spin of the electron mean? It means the spinning direction of the electrons. For example, we can define the clockwise spinning is spinning up and counterclockwise spinning is spinning down. The spin ups and spin downs are determined by the superposition of wave functions, which leads to an uncertainty of the spin ups or spin downs. If you are not catching up, it's alright, because neither am I. We can just admire how wonderful and mysterious quantum mechanics works. Let's make an easier analogy. Try imagine classical bits as a single note in a song, and 1 and 0 represent as different notes in the song. By putting them in specific combination, one bit at a time, you can get information from them. Just like playing one note at a time, with certain combination, you compose a song. However, in the qubits, it does not only play a single note at a time, it plays a chord at a time, which makes each qubit store more information. Also makes the processing speed of the quantum computer a lot faster than classical computers. There's a handful of applications that uses quantum computers. For instance, in the research of creating new medicines, it takes a lot of time and money to try different combinations of various molecular and get the right recipe. By using quantum computer, it can process tens of tons of combinations simultaneously, reducing both time and money that needed for the research, enable a faster development of the technology. Right now, there is still a long way from quantum computers to come true, because in real life, many things interact with the electrons, so the spin of the electrons cannot stay in the superposition states for a very long time. Although quantum computers may not appear in the near future, it certainly provides a brand new idea and thoughts. As for what will the future be, we can only hope for the best. Thank you for watching. If you like this video, please leave a like and see you next time.